Okay, so we're back for more of Chapter 4 notes, and we have talked about writing equations from words. We talked about some of the geometry problems, finding the missing angles of a triangle. We talked about complementary and supplementary angles, and we talked about consecutive integer problems. So now we're going to talk about systems of equations. Okay, and so a system of equations means two or more equations that have the same values for their variables. So if they both have an x in them, then x means the same thing in both. Okay, if they both have a y means the same thing in both. And for us, we're going to just be looking at two equations, okay, just because having more equations makes it a little more difficult than we'll get into in this class. So let's just think about why we deal with systems of equations for just a minute here. So let's just say over here that I have x plus 5 equals 10. Okay. Well, then if I'm going to solve for this, I can subtract 5 from both sides, and I can solve for x, and x is going to equal 5. And so this is the one number that would make this equation true. Okay. Now let's imagine that I have a slightly different equation. I have x plus y equals 10. So I don't know exactly what x and y have to be. I can come up with a whole list of options. So here's x, here's y. I could have x being 1 and y being 9. I could have x being 2 and y being 8. I could have x being 8 and y be 2. I could have x be 1.5 and y be 8.5. I could have x as negative 10 and y as 20. Any pair of numbers that would add up to 10. So there are actually an infinite number of possibilities here. Think about all those decimals also, right? Not just the whole numbers, integers, but also decimals. So those are these are some of our options. There are an infinite number of options for x plus y equals 10, for what x and y can be. Well, what if I also knew that, okay, not only did x and y have to equal 10, but let's say x minus y equals 6. Well, if I check these, and if I want my x and my y to satisfy both of those equations, well, all of the pairs in this little chart satisfy the first one. That's why we chose them. Let's also see what x minus y equals for each of these. So if I figure this out, for this first pair, 1 minus 9 is negative 8. Well, that doesn't equal 6, so that can't be it. 2 minus 8 is negative 6. That can't be it. 8 minus 2, there's my 6. If I look at the other ones, 1.5 minus 8.5 is negative 7. Negative 10 minus 20 is negative 30, right? So those wouldn't work. So of all the choices, I didn't look at all of them, right? They're an infinite number. But this is the one pair that is going to make both of these true. And so you know that there are an infinite number of solutions to the top one, to x plus y equals 10. There are also an infinite number of solutions to x minus y equals 6, right? I could have 9 minus 3, or 10 minus 4, or 466 minus 460, right? Anything that would have this. But the only pair that makes both of them true at the same time is to have x equals 8 and y equals 2. So if I have more than one variable, if I have two variables, then I need two equations in order to figure out the exact solutions. If I had 3 variables, I would need 3 equations. We're just going to be working with 2 here. So let's take a look here at this question. 2 numbers have a sum of 12. One of the numbers is 2 more than the other. Find the 2 numbers. Okay, so the first thing we always have to do, the most important thing, is to know what we're being asked to find. So we are being asked here to find the 2 numbers. So if I want to write out my let statements, I know that I'm going to need to find one number, so I'm going to just say let the first number equal, I'm just going to use x and y. Let the second number equal y. So now that we have our variables defined here, we know what we want to find, right? We want to find two numbers, one we're calling x and one we're calling y. So now we're going to have two equations that we have to write since we're looking for two unknowns. So one equation is going to come from this first sentence in this case, and the other equation is going to come from the second sentence. And we're going to think about those same things we thought about at the beginning of chapter 4, those key words. So number 4, sorry, not number 4 here, the first sentence is what I meant to say, says that two numbers have a sum of 12. So my two numbers, x and y I'm calling them, have a sum of 12. So think about what the word sum means. Well, we know it means the answer when we add. So this is just saying that my two numbers, x plus y, add up to 12. Okay, so that's my first equation. The two numbers have a sum of 12. Here's how we say that mathematically. The second sentence says one of the numbers is 2 more than the other. So is where our equals is, right? So one of the numbers is over here. It doesn't say which one. We don't have like one that's bigger, one that's smaller. So you really can use either one. I'm going to say x. So x equals, one of the numbers is 2 more than the other, right? The other number. So 2 more than that other number. If instead you used y equals 2 plus x, since it didn't really specify which number, at the end we'll have a certain number for x and a different number for y. You would just have them switched. Okay. So take just a minute, pause the video if you need to, make sure you understand where these two equations come from. The top one is saying that the two numbers add up to 12. The bottom one is saying that the one number is 2 more than the other one. Okay, so we have these two equations with two unknowns, and we're going to solve these with something called the substitution method. Okay, substitution method. So what we are going to do is we're going to look for one of our equations where it is solved for one of the variables, meaning that we want one of our equations to be either x equals blah, 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 or y equals blah, blah, blah. If we don't have one, we can rewrite one of these to be in that format. Okay, but we'll get to that in a little bit. So for right now, we notice that we do have this. So we have in this bottom equation, it says that x equals 2 plus y. Those two things are exactly the same. So even think about the little cards we made last week, right? We can pull out the x card and plug in the 2 plus y card, and it means exactly the same thing. So what we're going to do in that case is we're going to take this 2 plus y, and we are going to substitute it in for x right here in this other equation. Okay, so I have x in this other equation. But since x and 2 plus y mean exactly the same thing, then I'm going to substitute 2 plus y in place of x. So what I get then is 2 plus y equals 12. So make sure you understand why there are two y's there, right? In place of x, there's my 2 plus y in place of x, but then I still need that other y, right? Because I'm rewriting this top equation, and so I'm going to have 2 plus y in place of the x, and then plus y equals 12. Okay, now, what is the advantage of this equation that I see here? Well, the advantage is that now I only have one variable. So before I had two variables, I couldn't solve that with one equation. Well, now I'm down to one variable because I took out the x and I substituted in something with y. So now I can solve for y here. So I'm going to have 2 plus y is 2y. I'm going to subtract 2, and I will have 2y equals 10, divide by 2, y equals 5. So I know so far that my y equals 5. Now don't forget that I need to find both numbers. That was what it asked me to do, find two numbers. So in this case, you probably, since you know they add up to 12, you can probably do that in your head. But if you can't, or I want to just look at what the process is, I would, in order to solve for the other variable, in this case x, I would take either one of those two equations, plug in what I know for y, and then solve for x. Okay, so x equals 7, y equals 12. All right, so in order to check this, we need to check it, check your answers in both equations, okay? They can't just work in one equation and you say I'm good, because think about our example over here on the right in red. If I said, oh, x plus y equals 10, well, 1 plus 9 could equal 10, even though that doesn't make the second one true. So we want to find the values that make both of those true. So in the first equation, x plus y equals 12, 7 plus 5 equals 12. That does work. For the second equation, if I have x equals 2 plus y, well, x is 7 equals 2 plus 5. Yes, that does check, right? So there was one, and then here's the other. That also checks. All right, so you can check your answers in both equations. So we found two numbers that satisfied both of those criteria. We wrote two equations. Well, first we defined our variables. We wrote two equations. We substituted. That way we only had one equation with one unknown to work with at that time. Solve for that variable. Go back and solve for the other variable. Okay. So I would ask you to go ahead and try number 5 on your own. Okay. One number is 3 more than 5 times the second number. Together the two numbers add up to 75. Find both numbers. So again, we're going to start out by thinking about what we need to find and writing appropriate let statements. And then you're going to go ahead and write two equations for those. So go ahead and pause the video, see how far you can get on your own, okay, with writing let statements and then writing your two equations. Okay, so hopefully you paused the video, took some time to try this. So you're going to find both numbers, and it's just one number and another number, right? So let's just call them what? First number. And again, I'm just going to use x and y. You can use whatever variables you want. Make sure you're not using a variable that looks like a number. So if you use s, it has a tendency to turn into a 5 somewhere. Obviously, a lowercase l is not a good choice because it looks like a 1. So just little things like that. But otherwise, really, you can use any variable you want. Okay, so I have two numbers I'm trying to find both numbers. So I have an x and a y. So again, I have two equations that I want to write, and just the way this is set up again, one is going to come from the first sentence here. One number is 3 more than 5 times the second number. The next one is going to come from the second sentence. Together, the two numbers add up to 75. So let's go to this first sentence. And when we read this, you might notice that it sounds a lot like what we did in the beginning of the chapter, right? What we did last week. So one number is, well, we know that's our equals, 3 more than 5 times a second number. So one number, I'm just going to say that's x, is 3 more than 5 times the second number, right? So 5 times the second number, 3 plus that. Together, the two numbers add up to 75. Well, think about what that says. X plus y equals 75. Okay, so far so good, right? We have two equations. If you weren't sure how we got those, make sure you kind of pause and go back and see how we did that, or make a little note there and you can ask about that in class or in office hours. All right, so now we want to think about substituting. So I do have one of my equations set equal to a variable. So I have x equals 3 plus 5y, okay? So remember, that's good because now I can take that 3 plus 5y and I can substitute it in place of x in the other equation, and that will give me an equation with only y's. So what I get now is I'm going to rewrite this bottom equation, but when I come to x instead of x, I'm going to write 3 plus 5y plus y equals 75. Again, don't be confused by those two y's. 3 plus 5y all went in for where x was. And then I have the other y equals 75. Now though, I can just combine like terms and solve this. This is a relatively easier equation to solve. So I subtract 3, 6y equals 72, divide by 6. 72 divided by 6 is going to be 12. So y equals 12. Are we done? Not quite, right? We need to find what x is. So I can find x by using either of those two equations. So I could say x equals 3 plus 5y, x equals 3 plus 5 times 12. So use order of operations. And x is going to be 63. Okay. You could also have used the other one. So you could say x plus y equals 75, x plus 12 equals 75, subtract 12 from both sides, and I still get x equals 63. Okay, either one. And then at the end, you want to check. The check is not shown. The check would look very much like what I have on the right, except I'd plug in for the x once I have it and the y and make sure the two sides are equal. So either way, my x is 63 and my y is 12. All right, so these two that we just did really make us think back to what we did last week. They're called direct translation problems, where I just take some words like this, like one number is 3 more than 5 times a second, and turn it into an equation. So I'm trying to look ahead for a second here. Okay, so for the next one, we are also going to write two equations, but we have a little bit more of a context here. We're talking about people going to the movies and how much different tickets cost, and we have to know how many adults and how many children were in the family. So there's a little bit more of a context to it, but really when we get down to it, we'll be thinking about a lot of the same questions that were in thinking about it the same way as we were just reading the words in the previous one. Okay, so we'll kind of boil this context down to what it's really asking. Once again, always start, after you've read it a few times, always start by looking for what it's asking me. So this says a family of 8 people went to the movies. Adult tickets cost $11 and children's tickets cost $8. If the family paid $73 altogether, how many adults and how many children were in the family? So that's what I'm looking for, right? I'm looking for how many adults were in the family and how many children were in the family. Those are going to be my two unknowns. So what I want to do here also is be specific. So instead of just saying let adults equal X, I'm going to say let the number of adults, right? Because it's not about the cost of the adults or how old they are or anything. It's the number of them. And then let the number of children So for this one, we can use A and C if you want. Could be, we can make those lowercase just to kind of match what we had done before. Doesn't matter. Okay. So now we still have to write two equations, and they're very similar to what we had before. We just have to kind of pull that meaning out of these words. So the first sentence says a family of 8 people went to the movies. Okay, so 8 people went to the movies. We're going to assume all of them are either an adult or a child, right? Sort of the only options. So when I had this group of 8 people here, here's my family of 8. Okay, and some of them are adults and some of them are children, and we don't know how many there are of each yet. But we can find that out given the information, because if you think about it, if 8 adults went to the movies, it would cost a certain amount. If 8 kids went to the movies, it would cost a very different amount. Well, the same, it's kind of like a spectrum of between all adults with no children all the way to all children with no adults, or anywhere in there. I could have 1 child, I could have 2 children, I could have 5 children, right? And then the corresponding number of adults. So depending on where I am in that little spectrum there will determine what my cost is, right? Because all children, the more children I have, the less it's going to cost as compared to having more adults. All right, so I know I have the number of adults represented by A and the number of children represented by C. So I'm going to start an equation for you here, and I want you to, after I write this part, pause the video and see if you can finish that equation. So the number of the adults plus the number of children has to add up to something. So we want to think about what that has to add up to. So if you need to pause the video, go ahead and pause that for just a minute. Okay, so hopefully you're seeing, let's look at our little group of family members here, our little family dots. We want to think about, that some of these are adults. I don't know how many, but I'm just filling some of these in, and some are children. But I could never say, for example, that I have 2 adults and 3 children, right? Why not? Well, it's because of that first sentence, because a family of 8 people went to the movies. So I have to have 8 people in all. If I have 2 adults, I'm going to have 6 children. If I have 3 adults, I'm going to have 5 children. If I have 7 adults, I'll have 1 child. Because those 2 always have to add up to 8, because that's how many people I have. Okay, now, hopefully you're already anticipating that now I'm going to look at the second sentence and the beginning of the third one. That's what I'm going to use to find my next equation. So adult tickets cost $11 and children's tickets cost $8. Okay, so adult cost $11, children's cost $8. If the family paid $73 altogether, how many adults and how many children were in the family? All right, so this is where the value comes in, right? That $73 they paid goes with a specific breakdown of how many adults and how many children, right? So we said if there were 8 people and they're all adults, it's going to cost a certain amount. If there were 8 people and they were all children, it's going to cost less. That $73 is going to be somewhere in between there. So let's think about for a minute over here, just as sort of an aside, okay? What if I bought 1 adult ticket? Well, from up above, it says 1 adult ticket is $11, okay? What if I bought 3 adult tickets? Okay, well, think about how much money that would be. And you might just say, oh, it's going to be $33, right? But how did we get that? Well, we did 3 times 11. 3 tickets times $11 each. Okay, actually, I'm going to write that the other way. It doesn't really matter mathematically, but we'll make it a little easier in a minute. Okay, so I'm going to have $11 per ticket times 3 tickets. What if I have, pretend I didn't have to be, well, let's just do this. Say 7 adult tickets. I would figure out that amount by saying 11 divided by 7. Sorry, times 7. Right? So however many adult tickets there are, I multiply each one by 11, and that gives me the total for that number of adult tickets. What if I didn't know how many adult tickets there were? So I have X adult tickets. Well, I do the same thing, 11 times X. However many there are, I multiply that by 11 for each one. So that's kind of the basis of our second equation. So we have 11 times A. A is the number of adults, right? That's the same as the number of adult tickets. If I have 3 adults, my adult tickets are going to cost $33. If I have 5 adults, they're going to cost $55. Same idea here with the children. I have some unknown number of children. Each one gets a ticket worth $8. So 8 times C equals 73. That's how much money that equaled altogether. Okay, so again, as always, when you need to, pause the video, go back through what we just did, rewind it if you need to, or just look over what we have and make sure that what we have makes sense to you. If it doesn't, and you can't quite figure it out by looking back over it, then make a little note and you can ask me about it in class or in office hours. Okay, so now I have these two equations, this system. I notice now in this case, though, it's not set up for substitution. So since that's the only method we're doing right now, we want to make sure that it is. So we're going to take one of these equations. I'm going to take the top one because it's simpler. It doesn't have anything in front of the A or the C. And so if I want to solve this for one of these variables, let's say I want to solve it for A, then we know from the end of chapter 3 that we just follow the process like we normally would. So I want to subtract the C, and A equals 8 minus C. So this and this are exactly the same thing. They're just reworded. And you can think about the fact that this is where I get my A is exactly equal to my 8 minus C. So my 8 minus C is going to go in place of A in this equation. So I rewrite this bottom equation. Now, when I get to A, I'm going to substitute in 8 minus C. Because there's more than one term there being multiplied by this 11, I need to put it in parentheses. Again, though, you're seeing the pattern here, hopefully. The reason we did that is because now we only have C's in our answer. So we do have to distribute first. I will get 88 minus 11C plus 8C equals 73. 88 minus 3C equals 73. Subtract 88. Negative 3C equals, this is going to be negative 15. Divide both sides by negative 3. C is going to equal 5. So it's 5 children. That's what C means. Okay, now again, just for the process, obviously you can do this one in your head, but just for the process to show you that we would plug in 5 in either equation. I just chose the top one because it's a little nicer. Then solve for A. So A equals 3 adults. Okay. So we want to check this, right? And we can check it in a couple different ways. So A is 3. Here, just so we have it, and C was 5 children. Okay, let me just make sure this looks like a 5 and not a 6. So we can check it with our equations, but we may have written our equations wrong, right? So we want to really check it back also with the words. So a family of 8 people went to the movies. So 3 adults and 5 children, that does make 8 people. So that's good. Okay, adult tickets cost $11. Children's tickets cost $8. If the family paid $73 altogether, how many adults and children were in the family? So let's think about this for a minute. Adult tickets cost $11. So 11 times 3 is, this is the adult money, plus children's tickets were $8, yes. So 8 times 5, this is the children. Okay, if I want to see what this equals, this is going to be 33 plus 40. That does equal 73, which is what it told us that it should equal, right? So that is perfect. If we had the wrong configuration, if we had more adults, the cost would be higher. If we had more children, the cost would be lower. So just that one configuration, in this case with this information, is going to give you that correct total. Okay, so I'm going to stop this video just because it is getting kind of long and I want to break it up a little for you. So next time we're going to do some more equations in the next video similar to that, and then we're going to do some dealing with some triangles, and then we'll get into a little bit with inequalities. Okay, so I will see you in the next video.